Welcome, Math 30-2 group, and now I'm on the next part here, page 433, class example 2, which is dealing with the common factor of -1. So the beauty of common factor of -1, if you could see there's something common on top at the numerator and there's something common at the bottom of that rational expression denominator, then you could actually factor something called -1. So what do I mean by that? C minus 4 right now is at the top, but at the bottom is the opposite of that, 4 minus c. But so if you took out a -1 at the bottom, this becomes negative now, and the c would become positive. So this is the same thing as that, because it's just written with the negative front. So we usually don't write it like that. So we can rewrite it again if you like, to not get confused. So what I did down here, I took out a -1. Basically, I was saying, well, then I can make that factor of a -1, take that out, and then you could put c minus 4. Now they look alike. You can simplify from there by crossing out. But before we do that, keep in mind, state the NPVs. So what was the NPV for this? C cannot be 4. And what was the NPV for that one? Nothing, because it was -1. It had no variable with it. So hence the fact that was the only NPV. Now this crossed out becomes 1 on top, and then you have 1 over -1. Well, in the end, that's the same thing as saying -1, comma, c cannot be 4. Moving on to this one right here, what's going to happen here is that, well, it looks like you could factor things out here, and this is, you could factor this one out here too. Now, let me just make sure if I wrote that down, 16 minus 8p correctly, and that's correct, okay? So in that case, what is common with the 2 and the 4? A 2, and the p squared is common too. So I'm going to write that like that. Now over here, what do I have remaining? Well, 2p squared times what makes 2p cubed? Well, you should be realizing just another p. And then over here, 4p squared, what do you need to do from there? Try to 2. 2 times 2 makes the 4, and then that's it for that one. Over here, what is common with the 16 and the 8? Well, 8 is, so I could take that out. Now over here, 16, I need to times that by 2 minus, well, 4, because, actually 1 sec, it's 1, my apologies, 1 there, because 8 times 1 would make the fact of 8, and don't forget the p. Okay, now, this is the same thing as this, but unfortunately, you have to factor out a -1 there to make it look exactly like this. So I will do that. 8, take out a -1, rewrite this now as 1 minus, my apologies, this should be 1p minus 2. So from there now, I rewrote that as that. Now the top is going to be like that. Okay, so rewrite the whole thing so we don't get confused. So 2p squared, p minus 2, 8 is right at the outside, -1, and then inside the other bracket, p minus 2. Okay, find the NPVs here. In this stage, this is the only NPV that exists in this question. So p cannot equal to 2. Now we can start crossing things out. This is similar, this is similar. 8 and the 2 is similar in the 2 times table. So this becomes 4. So what do we have left over? We have a p squared over -4. So, comma, to represent p cannot be 2. At the same time, this is our actual simplification for it. This is class example 2. So now, what happens if we work on the next problem, which is dealing with this whole fact of area? So if we're dealing with area, what's going to happen in this next problem? You have to remember what the area formula is dealing with. So that's 434, class example 3, and there's 3 parts to that question, where the first part is that they give you the area, and at the same time, they give you one of the sides, which I believe is the length. So from there, you should be able to actually figure out what the other measurement is, because it's a rectangle. Now, I'm hoping you remember what the formula of a rectangle is. Well, if you don't, keep in mind area equals to length times width. So what happens then is that if it's area equals length times width, you have the area, you have the length, So you have to just divide now those amounts to actually figure that out. So let me quickly write down the question here. It's dealing with the area in meters squared of a rectangle plot can be presented by the expression x plus 6 squared. So the whole area right now equals to x plus 6 squared. X plus 6 squared. Now the length it's saying is that it's x squared minus 36. I can tell you right off the bat that looks like a difference of squares there, x squared minus 36. So next part, write and simplify a rational expression that represents the width of the plot. Well, as we know, area equals to length times width. Now we're trying to find the width. So in that case, width equals to area over length. Now area is x plus 6 squared. And then the length is x squared minus 36. Okay, we have to try to simplify that now. Well, how can we simplify that? Difference of squares here. You can expand the x plus 6 to make us look correct in us form. Now over here, the difference of squares, 36, 6 squared, here's the 6, and here's the subtraction difference of squares. So now here's the NPV stage, where you can actually state are the following. X cannot be negative 6 or 6. Okay, now what can we cross out? The plus and the plus. That leaves us with x plus 6 over x minus 6. This is what our width is. Now, the next bit, well, keep in mind, what was the measurement? It was in meters, so you should include the units. Okay, in B, it's asking, well, if the length of the plot is 28 meters, determine the value of x if x is greater than 0. So, area, the width, which is right here, the length of the plot is 28 meters. Determine the value of x. So that means you're taking the width, squared minus 36, and make it equal to 28. Okay, so now from there, add 36 on both sides, because you're trying to solve for x squared. Okay, then x squared equals to 8 and 6 is 4, carry the 1. Okay, square root, you're going to get plus or minus of 8. Now, keep in mind, this value has to be greater than 0, it's stated. So really, the measurement has to be, my apologies, has to be 8. Okay, for C, it's stating the plot has to be created with fertilizer at a cost of $2.40 per square meter. Calculate the cost of the treatment. Well, now keep in mind, we're taking the area because we're trying to find how much square meters there are. And we know that the length and the width, if we actually multiply them together, we'd have figured out another way of doing that. But you could just take the area. Area equals to x plus 6 squared. And we know that, well, we know that there's 240 per square meter. Well, we know that the length is 8 plus the width, which is 6, square that. So what's going to happen from there? 8 plus 6 would be 14 squared. Well, 14 times 14, it ends up to be 196. Okay, and then what do we have to do from there? There's 196 is the area. So now we have to times it by 196 times $2.25, I believe. No, $2.40. Okay, and then you're going to get $470.40. That's how much it will cost. Hopefully, if there's any issues or anything, let me know to clarify any of these concepts. Have a great night.